Welcome to all of you on the channel Maths with Muneer. I hope that you all are doing great and watching all my videos. Mathematics lives everywhere, but the problem is that we are not looking at things the way we have to. And one of the reason it might be because the concepts in students' minds are not clear. They are blurred. That is why they are unable to see the real picture. So I am quite sure that after watching my today's video, the way that you are looking at things, the angle, the way you are looking at things is going to be changed. So the topic that we are going to learn today is functions. So the question that can come up in your mind, that what are functions and why we often use them. So the function are often used for the repetitive task. Let us understand this with the help of a simple example so that everyone can understand. Let's suppose that this is the machine that you might have, and you are giving this machine some input, and you know the laws and the rule on which this machine actually operate after taking your input, and in results it gives you output. Let's assume that the laws of this machine is basically it's +3. I mean, whatever input that you are giving it to that machine, it will add +3 in that, and in return it will give you some output. So for example, you are giving 1 as an input, it will add +3 in that, and it will give you an output which is 4. If you give our input 2, it will add +3 in that, and it will give you 5. If you give 3, and then it will give you 6. So you see, for different input you are getting the different output. So the input that you are giving is actually varying. So we are going to represent this with the variable x. We have just learned with the help of this example that what are functions and why we often use them for the repetitive task. Now what I am going to do is that to make an equation with the help of the example that I have given. Since the input is varying, so I am giving the input the name x. We know the law that the machine is adding +3 in that, and it gives you the certain output. Let's assume that the output is your y, the input was x. So here we go, y is equals to x +3 is your equation. So obviously if we know the laws, if we know the rule of machine, that what that machine is going to do with the input, and you know the input, you know the law, then you can predict the output very easily. So y is equals to x +3 is a function. So we can also write y is equals to f of x, where y is a function of x. And over here we also know that the x is our input and y is what basically output. Y is output. We can also say that this x is basically your domain, and y is your range. Okay, for different questions, for different situation, we are using the different name. And we can also say that the x is your basically independent variable, and y is your dependent variable. Why y is dependent? Because the output y is depending upon the input that you are giving it x. So that is why we can say that x is independent variable, and y is dependent variable. There are thousands of examples that you can take related to the dependent and independent variable. Let's assume that the father and son relation. Father is earning all that money, he is working hard, that is why the son is able to go to the school, because the father is paying all his fees and managing all his expense. So son is depending upon the father while the father is independent. All right, so we have just learned that domain, range, input output, dependent and independent variable concept of a function. So how we will be able to know that whether a given equation is basically a function or not? So there are two ways that you can check always. One is mathematically and the other is graphically. So since I'm using this equation, so I'm going to take that y is equals to x plus 3 is basically your equation. So now we want to find out that what is the domain and what is the range for this function y is equals to f of x. We know that whatever value of x that you are giving, x is 0, 1, 2, 3, 100, or even if you are taking the numbers in negative, minus 1, minus 2, for minus 3 up to minus infinity. What does it mean by that? From minus infinity to plus infinity, whatever number you are taking in, it will always give you some output. So we can say that domain of this function is set of all real number and range is also set of all real number. Now what are real numbers? In order to understand real number, we have to go to the basics of number system, from where actually the numbers starting. So the first set that we have in number system is basically set of natural number, where the elements in the set are 1, 2, 3 and up to so on. We know that the basic property or the basic rule of mobile phone, that the first mobile phone that came, it has the ability to make or receive a call, or else you can send or receive a text across the globe. So whatever new mobile phone are coming into existence nowadays, they are making sure that they are keeping the fundamental property, they are keeping the basics with that. In addition, they are giving you some front cam, mobile cam, some are giving you the facility of internet and so on, much more. So whatever next set will come in the history of number system, they have to make sure that they are keeping the basics. So after this natural number, we have set of whole number, where the elements are 0, 1, 2 up to so on. So if you look closely, you will see that 1, 2, 3 numbers were the part of the natural number, they are part of whole number as well, plus 0 is the addition that we have in the set of whole number. Then after this, we have set of integers, where the elements are 0, plus minus 1, plus minus 2 and so on. What addition we got in the set of integer, that in this set we got some negative numbers, as well. So 0 plus minus 0 plus 1 plus 2 plus 3 and so on were the set of whole number as well. Alright, after the integer, the set of integer can be classified into much more. It can be divided into even number, odd number, prime number, composite number. This can be classified into many, so I am not going into that detail. Alright, after integers, we have set of rational number. So the definition of rational number is very important to understand for you. What are rational numbers? So all those numbers which can be written in the form of p over q, all those numbers which can be written in the form of p over q, where p comma q belongs to z. What does it mean by that? The elements that you are going to take p and q, they are going to belong to z, not from natural number or whole number. Why? Because so far the set of integer is the latest set that we have, and that is why we are going to take the element in set of rational number from it, because the natural and whole number are also part of it. Okay, if you write this definition till here, that would not be a perfect situation. Why? Because in p and q belongs to z, and in z we have 0 as well. We know that if somewhere you have a number in numerator p which is 2, or in denominator you are having q as 0. So 2 over 0 is an undefined form. That is what you can't take in the set of rational number. So it means that the definition is incomplete. We have to define a little more. So where p comma q belongs to z and q should not be equals to 0. That is the complete definition of the rational number that we have got. And in other words, we know that the set of rational number is basically a fraction. The number can be written in the fraction. You need to write your fraction always into its simplest form. Then you can decide that whether that fraction is a set of rational number or belongs to the set of irrational number. So I am going to give you some example and then we will see. Okay, the set of the examples of rational number are 1 over 2, 3 over 7, minus 10 over 21, and then you can take square root 16 as well. Alright, for these three we are so perfect clear that they belongs to the set of rational number. How about square root 16? We know that in denominator we always have 1. So the condition was p over q. So this is your p and this is your q. So I already made a point that you need to simplify your fraction into its simplest form. Then you will be able to say that from which category it belongs. Square root 16 is actually 4 because 4 square is 16 and square root will cancel. So 4 over 1. So you see the fraction in which you were confused earlier whether it's belong to the class of rational number or irrational number. Once you simplified it into its simplest form, now it's very easy for you to decide. So we can say that this is rational number. So what are irrational number? Irrational numbers are represented with the q prime, those numbers which cannot be written in the form of p over q. So in other words, all the prime numbers with the square root are basically the examples of irrational number, like square root 2, square root 3, square root 5 and so on. These all are examples of irrational number. So we haven't reached yet to the real numbers. So what are real numbers? So real numbers are basically the union of rational and irrational number. Once we say union, it means that we are combining the elements from rational number. So rational number already, do not forget that the rational number possess the properties of natural number, properties of whole number and properties of integer. So once you combine rational number and irrational number, then you are getting the real number. So y is equals to x plus 3. Over here the domain is equals to set of all real number, and also the range is set of all real number. Okay, so now let's move. We have so far we have learned about functions, why we use them. We have learned about the input output. We have also learned the dependent independent variable, and we have also learned the history of number system as well. Now the next thing that we are going to learn is that if you have been given a function and you need to identify that whether, if you have given an equation and you need to identify that whether the equation that you have is a function or not. So we can identify this with the help of two ways. So the first way is obviously it's a very easy way. It's a graphical method where we need to apply a horizontal line test or a vertical line test, whatever in which you are comfortable. So let's assume that this is the graph, and in this graph you have a function, you have any line, this. Now we want to check that whether the straight line that we have in this graph is a function or not. In order to do that, you need to apply a vertical line test or a horizontal line test. What does it mean by? Once you draw a vertical line on this graph, you will see that that vertical line is cutting your graph at one point only, or even if you draw a horizontal line, that will also cut the graph at one point, okay, like this. So it means that this is a function, it means that it's a function. So let's take another example. Let's suppose that this is an ellipse that you have, okay. So we want to check that whether this ellipse is a function or not. Simply apply a vertical line test. Once you draw a vertical line on this graph, you can see clearly that this vertical line cutting the graph at 2 points. It means that it's not a function. Or if you draw a horizontal line, that will also cut this graph at 2 points. Let's take another example. This could be your another graph, and once you draw a vertical line, you will see that that line is cutting the 1, 2 and 3 points. So it means that it's not a function. We will learn about the continuity of a function and its limit. So if you have got this video, please don't forget to subscribe and share as much as you can, because this concept is important for not only for A-level student but also for those students who are in their second year exam as well. And this concept actually started from the class 7th, then in 8th is little more advanced, then in 9th a little more, then 10th and so on. But the problem is that we are not realizing. So I hope that you got these videos. Please don't forget to subscribe and share.